The average annual cost of electricity used in retail buildings in the United States is $1.21 per square foot. For a box retail store, electricity costs can exceed $250,000 per year. In many climates, air conditioning accounts for 25 to 50% of these costs, largely because the need for cooling coincides with peak electrical demand, when electricity costs may be at a premium. Although newer variable speed air conditioners can reduce annual electricity consumption by 50%, they do not provide much savings during peak electrical demand. This is because the hotter it gets outside, the harder the air conditioner's compressor has to work to cool the air. Once the temperature gets high enough, even high-efficiency vapor compression systems provide minimal gains over standard equipment. This is not true for evaporative cooling technologies. They improve their efficiency as the outdoor air temperature rises, reducing both overall energy consumption and peak electrical demand. Evaporative cooling has been used for years with varying degrees of success. When they hear the term evaporative cooling, some people think of leaky swamp coolers. But evaporative cooling has successfully been used for decades in large chiller plants. After years of technology development, similar strategies have been created for smaller scale application on commercial buildings. Numerous modern evaporative technologies have proven effective through third-party testing, and customers are reaping the energy savings they deliver. One such third-party testing facility is the UC Davis Western Cooling Efficiency Center, or WCEC, the makers of this video. The WCEC researches, develops, and demonstrates technologies, including evaporative cooling technologies, that address both overall energy consumption and peak demand. A variety of evaporative cooling strategies exist for commercial buildings, and they can be categorized into two broad groups: condenser air pre-coolers and ventilation air coolers. This video will explain one evaporative cooling product called Munters Custom EPX. The Munters EPX is a dedicated outdoor air system, or DOAS, that provides all the conditioning needed for a building's ventilation air supply. It combines compressor-based air conditioning, indirect evaporative cooling, gas heating, and heat recovery all in one unit. Each EPX unit is customized to the particular specifications of a building, but in essence, they all work the same way. Let's take a look inside. There are two air streams that run through the EPX unit. The first airstream supplies ventilation air for the building. It enters the unit from outdoors and passes through the supply air fan. It then passes through the supply side channels of the heat exchanger, the evaporator coil of the refrigerant loop, and the gas furnace. It then enters the building. The second airstream is sourced from the building's exhaust air. From the exhaust fan, the air passes through the exhaust air channels of the heat exchanger and the condenser coil of the refrigerant loop. It is then exhausted outside. The EPX has multiple design features that allow it to minimize energy use while providing ventilation, cooling, and heating. During cooling season, the EPX uses several operating modes in sequence to conserve energy. In ventilation mode, outdoor air is delivered to the space when the building is occupied. As the outdoor air passes through the supply channels, the air is cooled by transferring heat to the building's exhaust air, which is moving through the exhaust air channels of the heat exchanger. This process provides ventilation to the building while efficiently maintaining the indoor temperature. In Stage 1 cooling mode, the indirect evaporative cooling process is activated. The EPX supplies water to the exhaust air channels, increasing the amount of heat transferred between the exhaust and supply air streams. This reduces the temperature of the air supplied to the building. The exhaust and supply air channels allow heat, but not water, to transfer between them. The humidity produced by the evaporative cooling process is exhausted outdoors so that no moisture is added to the building. When evaporative cooling can no longer meet the building's demand for cooling, Stage 2 cooling activates the refrigeration cycle to further increase the cooling capacity. The evaporatively cooled exhaust air is blown over the condenser coil before it is exhausted outdoors. This improves the performance and efficiency of the air conditioning process by reducing the temperature at which heat is rejected by the compressor. In ventilation mode, outdoor air is delivered to the space when the building is occupied. As the outdoor air passes through the supply channels, the air is warmed by transferring heat from the building's exhaust air, which is moving through the exhaust air channels of the heat exchanger. This process provides ventilation to the building while efficiently maintaining the indoor temperature. This heat recovery process contributes significantly to the EPX's annual energy savings. When additional heating is needed, the gas furnace turns on. The setup we described so far utilizes exhaust air to save energy in ventilation, cooling, and heating modes. However, certain buildings are not suitable for this approach. Restaurant kitchens have large heat exhaust loads, making exhaust air unfavorable for evaporative cooling. Industrial buildings that use fume hoods to exhaust building air do not have a centralized exhaust point. To address these limitations, the EPX is designed to provide an alternative installation option that uses outdoor air for the second airstream. Although this setup does not allow heat recovery from the exhaust airstream, the unit still provides efficient cooling by utilizing the evaporative cooling strategies described earlier. Munters EPX is effective in a range of climates and applications, but the energy savings achieved increases as outdoor temperature increases and humidity decreases. So the EPX is particularly well suited for hot and dry climates. Most of the western United States is suitable for the EPX. Munters EPX units have been installed in locations such as Santa Clara, San Ramon, Richmond, Chico, San Francisco, Sacramento, Las Vegas, Albuquerque, and Tucson. Independent lab and field tests have verified the performance of the EPX and demonstrated both peak demand reductions and energy savings.
We've seen very good performance over the 4 installations that we have. The one that we paid the closest attention to was the installation that we did in partnership with PG&E and UC Davis Western Cooling. We saw, again, about a 20% annual reduction in energy usage and a 20% reduction in peak load. So that was really exciting, and that's what was really the catalyst for us installing these units at other locations, including one other retrofit and 2 other new stores.
Of course, total energy savings depends on the specific conditions in which the technology is applied. As with any cooling efficiency strategy, greater savings are possible in buildings with large cooling loads and longer operating schedules. As mentioned earlier, higher savings are achieved when the EPX is set up to use the building's exhaust air for heat recovery and evaporative cooling. When installed in appropriate hot-dry climates, Munters EPX is twice as efficient as a high-efficiency compressor-based cooling strategy that conditions ventilation air and around 20% more efficient than other dedicated outdoor air systems with energy recovery ventilation.
So the Munters EPX, from my perspective, is more efficient than other ventilation strategies. The Munters EPX has really paid close attention to efficiency and increasing the EER.
A diverse range of customers have installed Munters EPX in a number of countries throughout the world and in the western United States. Customers include supermarkets, correctional facilities, a commercial printing plant, data centers, an airport, schools, and healthcare facilities.
We were first introduced to the Munters EPX system in, I'd say, mid-2014, where we saw it in PG&E's lab. It's 2017. We've installed 4 of them and are currently looking at other options for future retrofits and our new stores. California location, we use the EPX as the main sales floor unit. So bringing in direct outside air, if it calls for more than what we can obtain through the indirect cooling, obviously the vapor compression cooling would kick in. It's fine, but we're still gaining the efficiency. I would say 70%, if not more, of the year, because even though we see high ambient temperatures, a lot of times we don't need the vapor compression.
Munters employs a number of methods to minimize maintenance required on evaporative components. The geometry and materials used in the indirect evaporative heat exchanger are designed to shed mineral buildup. A bleed process removes concentrated minerals from the sump water. However, like any HVAC equipment, Munters units require ongoing maintenance to ensure that they continue to function reliably. Service contracts are available from Munters. Munters Service provides on-call technical support, extended warranties, spare parts contracts, and maintenance inspection plans tailored to the specific needs of owners. As with any new technology, it is important to have a foundation of service professionals that are familiar with maintenance and system operations when problems arise. Munters employs 60-plus service technicians located all across the U.S., including several technicians located in California. Customers can access Munters service technical support through the company's website or by phone.
So if something goes wrong with the Munters unit, the Munters team has been very responsive from both a warranty perspective. So there's at least 1 year warranty on the equipment itself and most of the parts within the equipment, whether that's control boards or compressors or the like. So they've been very supportive on that front, they being Munters. After the year warranty and even during the year warranty, we'll have preventative maintenance done by our outside contractors. There are not any, significant bells and whistles that any refrigeration or HVAC contractor shouldn't be able to handle. So they're not walking in and getting slapped in the face with something that they've never seen before.
Evaporative cooling technologies of today are designed to minimize water use and deal with a range of water supplies with varying quality. The money saved from reduced electricity consumption and peak demand can be used to offset the cost of the water used. The cost of a Munters EPX installation varies with the project details, including the size of unit, so we can't give a single cost estimate. But Munters sales and distribution channel partners work with potential customers to calculate the expected payback period before an investment is made. Of course, actual payback will vary in each circumstance, based on factors like hours of operation and the building's HVAC requirements, but many customers who have installed the EPX report payback in 3 years or less.
Return on investment for the existing facilities is between 3 and 5 years. If it is incentivized. If it's not incentivized, that is more likely to be 8 to 15 years.
Some customers in California have been able to secure custom rebates from the utility to install Munters EPX on their buildings. Of course, in those cases, the technology becomes even more cost-effective. EPX units are built in various Munters plants globally, depending on the customer needs and locations. Munters is a Swedish company that has been developing evaporative cooling technologies for more than 60 years. The EPX is sold to customers through a variety of distribution channels, including specifying representatives, or buy-sell reps. More information about the technology is available at the website, www.munters.com, in the Coolers and Humidifiers section of the Products tab.
I would absolutely recommend the Munters EPX. I think, again, proper due diligence to climate zone, building type, and what you're going to pair that system with in terms of controls and other HVAC systems that you may be employing at your given facility definitely needs to be paid. It's due attention, but I think it's a system that is definitely worth looking at.